strip of fabric hanging outside a window can stop 77% of the heat trying to push through the glass. That was not marketing. It came directly from measurements conducted by the Department of Energy. No futuristic coating, no expensive film, no $300 window replacement, just ordinary canvas stretched across a frame and mounted above the window. On west-facing glass, the reduction reached 77%. On south-facing windows, it hit 65%. The entire setup could be built with roughly $20 in materials from a hardware store. Your great-grandmother probably had them on every side of her home. Her neighbors did too. Even the White House relied on them. Then, around 70 years ago, they disappeared almost overnight across America. Not because they stopped working, not because a better solution arrived, and the price of abandoning them turned out to be enormous. The Department of Energy states it with brutal clarity. Roughly 25 to 30% of the money households spend on heating and cooling escapes through windows. In most homes, no other source wastes more energy. And the strange part is this: the oldest and cheapest solution vanished within a single generation. Most people never notice the key detail, but once it clicks, it becomes impossible to ignore. Curtains and blinds installed inside a room react too late. By the time sunlight reaches them, the radiation has already traveled through the glass. Some energy gets absorbed by the window itself. The rest pours onto floors, furniture, and walls, where it transforms into heat. At that point, the room is already warming up. Interior curtains are fighting damage that has already happened. Yes, indoor shades help. They may cut heat gain somewhere between 30 and 50%, but the heat is already trapped inside the structure. Exterior shades work differently. They intercept sunlight before it ever touches the glass. The energy never enters the home in the first place. The window remains cooler. The pocket of air behind the shade stays cooler too. Inside, the room temperature barely climbs. The air conditioner does not need to cycle constantly. That is the difference between blocking 30% after the fact and eliminating 77% before the problem begins. Same house, same window, same blazing afternoon. Only one detail changes: which side of the glass receives the shade. And contrary to what many assume, the room does not become dark. Light still filters through. You can still see outdoors. The harsh glare simply softens into diffuse brightness instead of direct solar blast. The room feels open and comfortable rather than bright and suffocating. The window is not being covered. It is being shaded the same way a porch roof protects a front entrance. And that distinction matters, because a $20 piece of canvas is preventing heat before it exists, while a $5,000 cooling system struggles desperately to remove it afterward. Then come the numbers. And this is where the story stops sounding interesting and starts sounding infuriating. The Professional Awning Manufacturers Association financed a study through the Center for Sustainable Building Research at the University of Minnesota. Researchers modeled a standard 1,700 square foot house across 50 American cities using DOE2 building simulation software. Real weather conditions were used, real window orientations, real glass types. In Pittsburgh, a home fitted with awnings on every window consumed 349 kilowatt hours of cooling energy during summer months. The identical home without awnings burned through 775 kilowatt hours. Fabric stretched outside the windows cut cooling demand by 55%. In Phoenix, annual savings reached $193. Across the Southeast, another analysis measured a 34% reduction in cooling expenses, along with savings of 3,453 kilowatt hours over a single year. Looking across all 50 cities, the study estimated savings climbing as high as $200 annually. And one detail deserves far more attention than it gets. During hotter than normal years, the years when electric bills become painful to open, the savings rose another 18%. At the same moment, air conditioning systems suffered harder under the exact same conditions. One solution costs $20, the other can cost $5,000, and only one becomes more efficient as temperatures rise. A homeowner named Michael Duffy from Manchester, New Hampshire, documented the results after adding awnings to his Victorian-era home. During peak summer heat, his porches and indoor spaces cooled by 10 to 15 degrees. He later explained to the New Hampshire Preservation Alliance that the awnings at least doubled how often the porch could actually be used. He reported only one drawback. Some of his houseplants received less sunlight. On cloudy days, he simply folded the awnings back, and the brightness immediately returned indoors. That was the entire compromise. A dramatically cooler home in exchange for slightly reduced sunlight during intense summer afternoons. Lawrence Berkeley National Laboratory later confirmed similar findings independently. In California climate zones, fixed and retractable awnings lowered cooling loads by 24 to 36%. The Department of Energy published those conclusions. Consumer Reports referenced them as well. None of these numbers are controversial. They have remained established for more than a decade. Now compare that to replacing the windows themselves. Installing modern energy. Efficient windows usually costs between $300 and $800 per window. In a home with 10 windows, that becomes $3,000 to $8,000. And even after spending that money, the heat reduction may only reach 25 to 40%, depending on the coating technology. Meanwhile, the $20 shade mounted above an old window blocks 77%. Someone could spend $8,000 replacing every window in a house and still fail to equal what a simple canvas awning accomplishes. Touch a west-facing window at 3 o'clock on a July afternoon. In Phoenix, the surface temperature can climb beyond 160 degrees. That heat pushes through the glass continuously while the sun beats against it. The air conditioner fights an endless battle hour after hour. Now imagine the same window protected by an exterior shade. The glass feels warm instead of scorching. The room behind it no longer resembles an oven. The air conditioner quiets down because the problem has been reduced before the compressor even activates. 77% of the heat disappears before entering the building. And none of this represents a modern breakthrough. In truth, it may be one of humanity's oldest climate control technologies. The Valeria of ancient Rome were enormous canvas systems stretched across the Colosseum. They were not decorative ornaments. They existed for thermal protection. 50,000 spectators sitting beneath Mediterranean sun required shade, so Roman engineers created retractable fabric structures operated by sailors from the imperial fleet. The rigging borrowed techniques directly from ship sails. Massive sections of the seating bowl could be covered beneath those giant suspended canopies. 2,000 years ago, the biggest public structure in the Western world was being cooled with fabric instead of machinery. Across the Mediterranean region, from Greece to southern Italy, from Spain to North Africa, societies living under brutal heat all arrived at the same answer. Roof overhangs, pergolas, canvas stretched above narrow alleyways between buildings, the whitewashed villages of Andalusia, the Medinas of Morocco, the island settlements of the Cyclades. None of those places were built around mechanical cooling systems. Every structure was planned around controlling where sunlight could reach and where it could not. Shade came first. Every later technology followed behind it. In the United States, awnings exploded in popularity during the Industrial Revolution. After the Civil War, sailmakers working with canvas began losing customers as steam-powered ships replaced traditional sailing vessels. So they adapted. They shifted into a different trade. By the 1880s, awning manufacturing had become one of the most widespread businesses in American cities. Storefronts carried them, houses wore them. Public buildings displayed them above nearly every window. Red and white stripes, green fabric, bold patterns stretching across sidewalks and porches. They served a practical purpose, but they also shaped the visual identity of American streets. Look at photographs from almost any town in the country before 1950. Window after window sits beneath shade. Every single block tells the same story. For more than 50 years, awnings were not decoration. They were the nation's primary summer cooling system. Not an extra feature, not an accessory. They were how people survived the heat. Then, the world changed. Willis Carrier introduced mechanical air conditioning, and eventually that invention entered ordinary homes. The technology itself had existed since 1902, but for decades it stayed mostly inside movie theaters, department stores, and industrial buildings. Residential window units began appearing during the late 1940s. By the middle of the 1950s, central air systems arrived in suburban houses. At nearly the exact same moment, architectural modernism declared war on awnings without ever saying the words directly. Design trends shifted toward flat surfaces, clean edges, and minimalist exteriors. Operating expenses every year can run from $600 to $2,000 depending on climate conditions. Then, after roughly 15 years, replacement becomes necessary all over again. And every kilowatt hour consumed by that equipment adds slightly more heat to the planet, which makes the following summer a little hotter, which forces air conditioners to run even harder. A cycle feeding itself over and over the more people depend on it. An awning interrupts that cycle instead of accelerating it. Picture the scene. Saturday morning, 4 windows, maybe 5. The west-facing ones, the south-facing ones. The windows hammered by sunlight every afternoon from May through September. PVC pipe, canvas fabric, 1 hour of work, maybe 2 if measurements get checked twice. Then afternoon arrives. At 2 o'clock, you step into the room that always became unbearable during summer, the west-facing bedroom. The living room dominated by large windows, and suddenly it feels ordinary, not cold, not overheated, just normal. The glass no longer radiates heat into the room. The air near the window stops shimmering. Place your hand against the pane and it feels warm instead of burning hot. The air conditioner has remained silent for more than an hour. That silence is the awning doing its job. You do not experience cooling being added. You experience heat being prevented. And tomorrow it keeps working. Next month too. Next summer as well. No filters needing replacement. No refrigerant refills. No technician appointments. Perhaps the fabric eventually wears out after 8 or 10 years. The frame itself may outlive the entire house. And this is the part impossible to stop thinking about. Every building in America once used these systems. Not a few buildings. All of them. houses, schools, courthouses, storefronts. After the Civil War, canvas sailmakers built a massive industry around awnings. For 70 years, exterior shades were America's answer to summer heat. They functioned across every climate and nearly every building style, at a price ordinary families could actually afford. Then society invented a machine capable of doing the same job at 10 times the cost, while consuming 100 times more energy. And instead of placing the machine beside the shade, America removed the shade completely to make space for the machine. A $20 system stopping 77% of solar heat before entry was replaced with a $5,000 system battling all of that heat only after it invaded the home. Then the country forgot the shade had ever existed. But physics never changed. Summer sunlight still sits high overhead. Winter sunlight still arrives lower across the horizon. Fabric still blocks heat exactly the same way it did when Romans stretched massive canvas covers above the Colosseum. The only real difference is this: almost nobody profits from reminding people. Windows remain the weakest thermal surface in most homes. A $20 awning solves 77% of that problem from the outside. But windows are not the largest surface the sun attacks. That target is the roof. And one homeowner reduced attic temperatures by 40 degrees using nothing more than a $14 layer of reflective paint. Same concept, same physical principles. Another low-cost solution almost nobody talks about. If this kind of hidden history matters to you, keep digging deeper. It's because the most powerful solutions are often the ones civilization already discovered long ago and somehow chose to forget. Thanks for watching. See you in the next one.